Hello, it's the 26th of January for Advanced Maths and Graphics at Goldsmiths. I've been told to research 2 rendering engines and write about the recent trends of rendering engines. So I made a presentation and I narrate over that. I didn't realize with narration you can actually break it down per slide, so this is just a one take, doing it live kind of thing. So might not be very good, but enjoy anyway. The first renderer we'll look at is called Maxwell Render. Here are some pretty pictures made from it that I found on the internet. It's a third-party render engine based on the physics of light and on the principles of photography in its setup and operation. What attracted me to Maxwell is the idea that I can make a model in SketchUp and Rhino, or a majority of other 3D packages, and then export it and import it into Maxwell to render it. And that idea makes it an extremely attractive tool to work with. So I loaded up the trial period of Maxwell to test it out. It was all pretty good. There's no texture or shader quick preview, so you have to quickly render the scene. And unless you choose one of the shaders, like for instance the Maxwell Dielectric, which is like transparencies, or the Maxwell Emitter, which is sort of like light, you aren't going to get any color. There's lots of other great features though. One I particularly liked was the layering of materials, so you can build up a nice grime effect on top of textures. And I hear it's a lot more robust and advanced in the full version. The materials and options are pretty simple and straightforward to create nice effects. You can just text your object really easily, and you can make adjustments to the scale, UV mapping, and color as needed. I used one of the tutorials I found online to render that game crate you see in the bottom right corner relatively painlessly. I had a few crashes with it once it stopped the render, so I had to make a couple more adjustments to the lighting and materials than I would have liked to. Aside from the location of the lighting feature, Maxwell worked very well. I think it'd be a very useful tool, especially if it's compatible for plugins like SketchUp. Fortunately, it's only compatible with the Pro version, so I didn't get to get my hands dirty with that. The second engine is the Indigo Renderer, and I picked this because of the quality of the images you can produce, especially with sort of like material texture that you can see at the bottom right. So again, I loaded up the trial version. And Indigo, like most of these render packages, come with some trial scenes. That was the caterpillar at the bottom left. Unfortunately, it's quite a technical and esoteric scene that makes it difficult for a newbie like me to understand how the program works. So instead I decided to install the plugins for SketchUp and Cinema 4OD, which was very straightforward. And I like this because it's really exciting how fast you can get really great images out of SketchUp this way. This is really cool because before this rendering package I thought SketchUp could give you just these boring flat 3D shapes, and now you can actually do stuff with them. And it's really useful for architects who don't want to get too involved with behind the scene purposes. There are a few tutorials online on manipulating a Google SketchUp model. Unfortunately they peak at sort of basic shape manipulation, so I can turn things into frisbees relatively easily, and I can't see the jump between that and these amazing scenes you see on Indigo's online galleries, and I think it's just because there isn't a sort of like a user interface for people who aren't die-hard Indigo artists. Here's an artist I really like whose name I can't pronounce. These are some incredible images that just look like they've taken forever to render. And he states that he uses the Indigo Render farm, which gives him 4 CPUs for a fraction of the cost of the rendering time it takes to create these images, which I think is really neat. All in all, I think Indigo needs to be more intuitive and user-friendly, which is such a shame because you can see from these images, it's such a powerful tool in the right hands. Now we're going to talk about some recent trends you can see in these renderers. There are some very general things like a what you see is what you get editor that helps you render the environment. And we're also seeing just general improvements to the software. So quicker rendering times, super realistic materials, for instance. The big challenge for renderers is to model light correctly. Obviously tracing every particle of light in a scene is completely impractical and would take huge amounts of time, even if you get a small sample of light. So there are loose families of more efficient light transport modeling techniques that have emerged, like rasterization, scanline rendering, geometrically projecting objects in a scene on an image plane, recasting that's taking the specific point of view of an object, and using the Monte Carlo technique to reduce artifacts. This Monte Carlo technique is to use random sampling when it is infeasible to compute an exact result with deterministic algorithms. We also use radiosity to calculate the passage of light as it leaves the light source and illuminates a particular surface. Here are some of my other favorite features that have evolved and as a result of advanced rendering software. So you have procedural object creation, and when I think of on-demand object creation, I think of all the bugs in Starship Troopers running down that desert hill. You have 3D motion blur, so you can see in the bottom right you have your sphere, which is a nice little blur effect to it. You have advancements to the frame buffers, so this is advancements to the video output, and HDR imagery, so you now can better define the dark and light areas of a photograph, and so you can represent the contrast better in these images. And that's pretty much it with rendering engines. I hope you have thoroughly enjoyed yourself. Okay.